So today we'll be talking about how to balance chemical equations. We'll be applying Lavorier's law of conservation of mass onto how to solve, balance, and then finish up by writing out what kind of chemical reaction it is. But before I start on to actually teaching how to balance a chemical reaction, I need to go over some vocabulary first to make sure that people know what's the difference between an atom and a molecule and a compound. And what does that have to do with chemical reactions, with products and reactants, okay? So atoms. Atoms are really the building blocks of matter. That's a really famous quote. Building blocks of matter. They're the elements that you see on your product table. Elements. So when you think of elements such as carbon, when you think of it as hydrogen, carbon, hydrogen, oxygen, these are all elements in the product table, but they're also atoms, okay? Now the next thing after that is molecules. Molecules are made up of atoms. When you talk about a molecule of water, of dihydrogen monoxide, you think of it as consisting of elements or atoms, 2 hydrogen and 1 oxygen, which we call dihydrogen oxide, but for convenience sake, we always call it as water and nothing else. Right? The other thing I want to talk about is compound. Compounds are molecules. Everything that's a compound is also a molecule. But what's the difference is that compounds are made of more than just one element. Made up of more than one element. So when you think of water, water is a compound because it has hydrogen and oxygen, 2 different elements. But when you think of something, for example, of oxygen gas, that the ones that we breathe in, or when you think of, what's another gas? Fluorine gas, really toxic, burns out your lungs. These ones are not compounds because they only consist of 1 molecule. They're diatomics. 2, di meaning 2. And compounds have more than 2. Alright? So that's a little basic vocabulary of products and reactants. So in a chemical reaction, we have the products and the reactants. When you think of something, for example, this chemical equation, I'll use this one. Copper oxide, so plus helium gas, hydrogen gas, will give me copper solid and water. Can someone tell me which side is the products and which side is the reactants? Right? The right side is the
product?
product, correct. And the ones that are on the left side are the reactants. Products are the result of a chemical reaction. And the reactants are your initial things, or compound molecules, that undergo chemical reactions. I'm going to use the letter RXN, meaning reaction. It's a little abbreviation. So RXN is equal to reaction. It's another vocabulary. So now how does all of this relate to conservation of mass in balancing chemical equations? Well, first of all, let's recall conservation of mass from the last class. Conservation of mass, what does that say? Well, conserve mass. Basically, what it's saying that mass cannot be created or destroyed. Atoms, building blocks of matters, are not destroyed. They are conserved in a chemical reaction. And we can see that through here, this one chemical reaction right here. So in this reaction, we have copper oxide and hydrogen gas, call it solid copper. So here we have 1 copper and 1 copper here, correct? We see an oxygen here, and an oxygen here, and hydrogen here, and hydrogen here. You don't see the entrance of, for example, another element, for example, like, you don't see any nitrogen appearing on either side and not appearing on the other side. You don't see any versions of iron, per se. You see? So that's how the conservation of mass kind of applies to plastic chemical equations. All right. So with the floor on this demonstration, I would like to invite 2 students to come up here in the front with me. Ryan and Kai. One of you guys will be holding, both of you guys will be holding both sets of equations. So this is going to be yours, and this is yours, and these 2 are yours. Alright, so this is an iteration of what I just said. So the copper one is demonstrated by the green atom. The oxygen is demonstrated by the blue, hydrogen is by the white. As you can see, can you guys both count to me how many molecules of, Ryan, so count how many molecules of the white molecules do you see in your hand?
2.
2. Perfect. And can I tell how many of white do you see on your side?
2.
2. Whoa, math is the same. All right, let's try about copper, the green one. How much do you have on your side, Ryan?
1.
1. Garcia?
1.
1. And now for the oxygen, the last one meaning the blue.
Just 1.
It's 1, and the oxygen
One.
is 1. Exactly. As you notice, that things start matching up. So when you guys sit down now, and you see here we have your table in your worksheet. Copper, oxygen, and hydrogen. The reactant side and the product side. You have 1, 1, and 2. 1, 1, and 2. So they're balanced. So this is what you see as a balanced chemical equation. And you see whatever's on the left-hand side has the same amount on the right-hand side. 2 hydrogens right here, and then 2 hydrogens right here. Now, this sample was really easy because we didn't have to balance it. But what if I gave you, if I said something, for example, hey, can you demonstrate me or write me the balanced equation of the combustion of methane, for example? Well, first, you gotta know what methane is. Methane is, look it up, CH4. Combustion, meaning to oxidize and to explode. We need oxygen in it, so O2. And then what happens in a combustion reaction? Well, you will form carbon dioxide and water. Now count for me, whether or not this is balanced. You have 1 carbon on each side. You have 4. Let's write this up. Reactants, products. 1 on each side. How many hydrogens do we have? 4 and 2. Correct. And how many oxygens do we have, Brandon?
2.
2. And then Michael, how much do you have on the product side?
3.
3, indeed. Is this balanced?
No.
It's not. It's not balanced. Because you see a 4, 2, and there are 3, 2 here. So what's this say? Well, this is not balanced, and this is not actually how chemical reactions actually result in. You don't form 1 carbon dioxide with 1 methane. You don't form 1 hydrogen, 1 water with this reaction. What you need to do is balance them. Now the question is how? First of all, what you're going to do is start counting up 1 of the molecules. You see carbons here already balanced, so we don't have to touch any of the carbons. But what do you see now? Hydrogen. Well, let's try balancing the hydrogen first, and we'll leave oxygen second for that reason. So we added 2 in front of there. So now count how many hydrogens we have on the right side. Instead of 2, we have 4. Well, that sounds balanced. However, well, the oxygen is not balanced anymore because now we have 2 water. And how many oxygen molecules are there? 2 and 2, and there's 4 here now. Hold up. We just made more oxygen. Is that okay? Yeah, because we can always add more. And that's why we leave oxygen last. We can always put a 2 in front of it, and then it will result in, when we look at this, we see, oh, hey, there's 4 oxygen. Now, when we look at this equation, doesn't everything look balanced? Yeah, there you go. All right, so
6 minutes.
6 minutes left. Okay, cool. All right, so now let's move on to another example. I don't need this vocabulary anymore. I can spend a minute erasing. All right. The next question that we can do is this one. Very famous and very, very important to our life, our living system and today. Photosynthesis. Can someone tell me where does photosynthesis occur? Right?
In plants.
In plants, specifically in the cells of plant cells, in the leaves. There's a reason why they're green, and also what does it do for us? Well, everyone knows that it takes carbon dioxide and it takes water to make what? Right. Right, you're my teacher's pet.
I don't know what it makes.
Oh, okay, that's fine. Good question. Well, let me tell you. You make glucose, sugar. Sugar, things that we eat. Sugar as in comes in fruits or even supplies that results in plants using it to grow. Because plants grow too, and they also need sugar. Oops, there's not 3 6 there. Alright, so same steps as we did before. First thing, when it comes to balancing chemical equations, I like to balance all the carbons first. You see, how many carbons are on the right hand side? We see here reactants and products. So let's balance all the carbons first. Balancing carbons. All right. There's a 6. There's a 1 here. So let's make this into a 6. So let's write it up. 6. Now what? Okay. Now the carbons are balanced. That's not a problem at all. But then we leave oxygen last. Now balance out the hydrogen. You see 12 hydrogens here and 2. How many times does 2 fit into 12? 2 divided by 12 would be 6. So I would need 6 equivalents of water. This is the chemical equation. Alright? So now we have 12 hydrogens here and 12 hydrogens here. That's balanced. Okay. Now what's the last thing we do? Now we touch up the oxygen. Let's count. 6 times 2, we have 12 oxygen right here. 6 times 1, there's 6 of them right here. There's 6 oxygen over here already. And then there's also, now we're going to balance this one. How much do we need? Well, this 6 and this 6 cancel well. So I really need 12 in total, correct? But since it's it comes in a multiple of 2, like a bundle of 2, you're going to need to take that divided by 2, and you get 6. So you need 6 equivalences. In total, you would have a total of 18 and 18. Now you have your chemical equation all balanced out. Right. Something to keep in note though is that you would like to make sure that you guys include and don't miss out this oxygen over here. Some people just go straight into, hey, I see 8 oxygen right here, and they go straight into being okay. So there's it's not total of 8, sorry. There's a total of 18, so I need 9 equivalences. No, you already have 6 right here. So always include all the elements whenever you see it appears in a molecule. This is a molecule, this is a molecule, these are compounds as well. Okay? Alright, so I think that ends our today. For our next lesson, we will talk more on what happens when you result in an unequivalent chemical unbalanced equation and odd numbers or half digits. And for homework, I can assign you to do the next 3 questions on the board. Okay? Thank you very much. And that will be all for today.